So today we're going to do experiment 18, which is the, I always call it the acid-base titration. And so we're going to be looking at using a drop counter instead of a burette. This is the burette we're using. It has this burette. We're not actually going to take the measurements on it. We're going to let the computer take the measurements. And this has what we call a double stopcock. The double stopcock is to help us control the rate that the liquid is going through the end of here, because this is a drop counter, so we have to have air between each drop so we can count it. And so the bottom one is your on-off valve, and your top one is to control your rate. And so without even starting yet, I'm going to open up the bottom one, because that's what you're going to do. You're going to open this one up full up, and you're going to change the rate in the top one. I'm going to try to center this a little bit. Change the rate in the top one, and I have it set really well. You can notice that there is space between each drop coming through. The only thing that I might do is lift this up a little bit. I think this is a little bit too low, because you definitely want the dropper, this drop counter to count the drops. So that looks good. Okay, so I'm going to turn this off. And one thing that we need to do is we need to calibrate. We need to find out how many drops are in a milliliter. And so for our LabQuest, we're going to calibrate this. So I already have the drop counter is connected up with the volume. And on here, when I touch it, it says calibrate. When I hit calibrate, it's going to say, it says calibrate now, and so I'm going to hit that and then turn on the stopcock, and it's going to start counting. And then I'm going to put this down, and I'll bring it back up because I only have two hands. So I'm going to hit calibrate now, and nothing's happening because I haven't opened this up. I got to make sure my graduate cylinder is underneath so it will catch every drop. So it's catching every drop right now. And I want it to collect volume until it reaches about 9 milliliters. So on here, you can see that the drop counter, I'm going to have to redo calibrate. Oh, 23, here it is. 24, it's already counting up to 27 drops. Okay, so you can see that it is counting each drop as it's going down. And we just have to sit and wait. So we're at 8.5, we're waiting it to reach up to 9 milliliters. And so far I've got 180 something drops. Once it reaches 9 milliliters, first thing I'm going to do is stop the stopcock first, close that. That's what I'm going to do now, is I'm going to close the stopcock, make sure all the last drops are off. And there's like one drop left. Come on. Doesn't want to let go. And then I'm going to read the actual volume. And the volume I'm reading is 9.1. And so in my dialog box here, I would enter 9.1 milliliters. I would say okay to that. And it's only reading 6.9, so that means I have to redo this. So I'm going to redo this off camera, and we'll try it again. Sometimes it does happen where it's not reading it correctly. Maybe I'll clean out the inside there, but we're going to have to recalibrate, and that's what I'm going to do right now. Volume is reading, oh gosh, 1.2 or 9.2. So I'm going to put that in here as 9.2 and hit OK. 9.099. So it is calibrated. It's within a half a milliliter. So we are ready to go. So I just have a big waste beaker off to the side, then putting my waste to collect all my waste in. In the burette itself is 0.1022 molar sodium hydroxide. And for my experiment, I'm actually going to fill up my burette because I don't want to run out halfway in between. Now I'm not going to use the burette to record the volume. I'm going to let my drop counter do that. We have a couple of other things that we need to add to our, in fact, I'm going to take off this temperature one. We don't need the temperature. What we do need is our pH meter, our pH probe here. Now our pH probe is hydrogen, it's a hydrogen standard, so we're actually looking at the difference, the voltage difference between our hydrogen probe in here and the solution that we're going to be measuring. And so I need distilled water so that I can rinse my burette. Now the pH, not burette, but pH probe. My pH probe is stored in our solution, and we need to rinse the burette really well, our pH meter really well. If you'll notice, the pH probe here on the bottom there is a bulb. It is very, very, very thin glass. It has to stay wet, otherwise it will crack. That's why we store the solution, the probe in a solution. And so and we don't want to break that at all. And so we also wipe our our pH probe with our Kim wipe. Now this probe actually sticks into our drop counter through a hole here. Okay. The other hole is for a thermometer, but we don't need that for today's experiment, so we're not going to do that. I'm going to need a stir plate. Now I'm not going to use this as a hot plate. I'm going to use it as a stir plate. I'm going to stick my pH probe into my LabQuest handheld, and you can see that the pH is now reading up in here. Okay. What we're also going to do, and we don't want that in the air for too long, so for a couple of minutes, if I'm not using this, I'm going to actually store this in the solution. Okay. I need to get my titration ready. I'm going to assume that the probe is already calibrated. So I calibrated my volume for the drop counter. Sodium hydroxide is in the burette. I'm going to be using our unknown acid, our liquid acid, to put into our 150 milliliter beaker. Now I have the acid, I poured it into a small beaker because remember, you're not going to pipette directly out of the reagent bottle. You're going to use a 25.00 milliliter volumetric pipette, and we're going to pipette up 25 milliliters. Ugh. Nope. This pump is not working. Is there another pump there? It's in the drawers in the weigh room. Some of these work better than others. Nope. Thank you. Okay, so I'm going to pipette up 25 milliliters. Notice there's a lag time. So when I move the wheel up, it brings up some volume. You guys know how to pipette already because we've pipetted so many experiments so far this semester. And I did not give myself enough liquid. So I'm going to add a little bit more. So I'll make sure I have no air bubbles as I draw up the volume. And remember, there's on the neck of the pipette right here, I want the bottom of the meniscus to go to the top of that line. All right, so once I reach that bottom of the meniscus to the top of the line, I'm going to transfer this liquid into my beaker. It just takes time for 25 milliliters to come through a tiny little hole. All right, so recall that I have this against the wall of the glass, and a little bit of liquid is calibrated to stay just in the tip. Okay, so we're going to take and put down our pipette. This is our liquid. I'm going to add, that's our acid. I'm going to add some phenolphthalein indicator. Recall we used this before. It is clear and colorless in acid, but it is pink in base. I know it doesn't say to add that to it, but we're just going to add the acid so that, the indicator so that we could see a color change. And then it says to add like 30 milliliters of water, and that's what I'm going to do. I just need to add additional water. I'm not changing the moles of acid. I'm just adding water to it. I'm also going to get my pH probe ready. I need to rinse it. Anytime I put it in some solution, I need to rinse it so to make sure that the solution is off of the probe. I'm going to just take it down. All right. The other thing I'm going to add to my probe, and I might have to lift all this, is a spin collar. The spin collar is magnetic, and so when I turn on the stir, I'm turning on the stir is not working here. All right, so when we start, the stir bar will stir with the magnet. This one has a magnet in it, so we can use this one. This goes right on the bottom of our pH probe. So we don't want it too high where it's going to hurt the probe, but we want it low enough that it's going to be able to go in the liquid. And like I said, I think this is too low. Maybe. Yeah, I need to, that's too low. I need to lift everything up. And sometimes you have to adjust things in your experiment. That's always a possibility. All right, so we have all this wires you have to adjust. So we have our pH probe in there, and the probe needs to be in the solution, but where the stir bar can stir. There we go, a little bit too high. Need to be able to have our drop our burette right above. So there's a happy compromise in between. So when we are ready, the pH in there is an acid, so you notice pH is below 7, 3.74. The volume is reading 0 because I haven't added any of my base yet. So I'm going to go to the graph, and to graph this, to actually collect my data, I'm going to hit go. I'm going to hit go, and you'll notice this circle going around. That's because I haven't started the stopcock yet. So once I turn this on and the drops start going, it's going to measure, for each drop, it's going to measure the pH. And if you look at your solution, you can see that each drop, the phenolphthalein, is turning pink every time it switches, and that's why we're stirring the solution to get the base and the acid mixed. And you can see it's collecting data in real time. And we're going to actually watch it go past the equivalence point. When we've done this experiment last semester in Chem 103, we stopped the experiment right when the phenolphthalein turned that pale pink color. Here we're going to watch it turn pink and go way beyond it. So we actually want it to go fuchsia. And so you can see right now that we're adding a base to our acid, but it's not neutralizing it yet because we have a weak acid in here. So the acid that we have is a weak acid. And recall, when you neutralize some of that weak acid, it forms a salt or the conjugate base. And when you have the weak acid and the conjugate base present in the solution, you have a buffer. And we just, last week we did an experiment where we showed that a buffer resists the change of pH. So we're going to have a whole time where we have a buffer solution and the pH is not going to change all that much. And the weak acid that we are using is a monoprotic acid, so it only has one hydrogen. So the screen, obviously on this LabQuest, sometimes goes dark just to save energy, but I plugged it in so we don't have to worry about that. And you can see this, the pink is starting to take a little longer to disappear as we're going on with the titration. The pH is reading just a 4.9 right now. You can see the little pH is reading right there. We've added 7 milliliters of sodium hydroxide so far to our 25 milliliters of acid. We're going to walk around to turn the lights back on. I just shifted the experiment just to get the stir just a little bit more centered. And just like we did last semester, when you get close to the equivalence point, you'll see that it takes longer and longer for that pink solution, for the phenolphthalein, to go colorless again. And one drop will make the whole solution go from clear and colorless to pink. Notice it's taking longer and longer for that pink to go away. We're getting close. One drop and it'll stay pink. There we go, we hit the equivalence point and the pH is jumping up to 6.7. It's going to be fuchsia pink, it's already at 7. You can see it's jumping up. Now it's at 8, and pretty soon you're going to see in our graph it'll plateau out. It's at pH 10 already. pH 11, it's starting to top out. And you can see that here's our buffer region, this long flat region, and all of a sudden it jumps in pH and it's going to level off here. We're at a pH of 11. Remember, the scale only goes to 14. Once we get a large enough upper plateau region, because you need a large enough upper plateau region to analyze your data, then we'll stop the experiment. Just a few more. But you can see it is nicely leveling off right here on the top. So we have our initial pH, our buffer region. Halfway between here is our equivalence point where we have the same moles of acid and base, and our upper plateau region where we just have only base present. Once we figure out the equivalence point, at half the equivalence point is what we can use to find the pK of our acid, pKa of our acid. I think that's good enough for the upper region. So the first thing I'm going to do is I'm going just to stop, and then I'm going to turn off the stopcock. And you can see our nice graph here where we have our lower plateau region going through the equivalence point and our upper plateau region. We're going to do this experiment a second time, and then we're also going to do it with a solid acid instead and get the very similar data. I'm not going to demonstrate the solid acid part because the experiment looks just exactly the same, except for I dissolved up acid instead of using a liquid acid. And then I will be sending data for you to use to analyze your data to figure out the equivalence point for each of your acids, and also the half equivalence point, and also the concentration of your unknown acid. That's the other thing that we're going to be looking for. All right, well, this is what our experiment looks like, and this is the end of our acid-base titration.